Okay, quick and dirty video to show how you can use a lathe to test Jorn's proposition that you can locate a conductor outside of a rotor in such a way that there is no net EMF. What I've done is taken a foam rotor and put only 2 magnets into the edge. I have a high permeability toroidal core with a few windings. I am feeding it a small voltage from a nickel metal hydride battery, and I am performing what's known as the closed loop test. This is a oscilloscope probe, and we have the trusty 465B. It's at present set at 10 millivolts per division. So now we're going to start the lathe. For those of you who like math, I'll tell you the time base and you can figure out the RPM. But for the purposes of this demonstration, I'm merely trying to show an approach to exploring canceling EMF. I should also say that I've made no attempt to field balance the 2 magnets that are in the rotor at the moment. So I'm going to use this wheel, which will move the toroid and the coils from left to right across the magnets. So I'm going to move it to its far position. Here is the scope trace. You can see that because it's on a 10 millivolt scale, peak to peak, you're looking at under 40 millivolts, and those are maximum and minimums of probably about 18 millivolts. Now I'm going to move the toroid across the edge of the rotor. You'll notice that the EMF peaks are reducing, and we'll continue to do this. I believe that's about the minimum, roughly speaking. We'll go a little bit further. And for the setup as it stands, it looks like we're down to plus or minus 10 millivolts. Remember that the system is being fed, that coil is being fed continuously by a 1.2 to 1.3 volt supply from a battery. Okay, I'm going to continue to move the coil across the face edge of the rotor. Basically, when I'm doing this, I'm moving it in the Z, and you'll see that the peaks go higher, and then as I get quite far away, they begin I'm now so far away that there's little EMF being generated. The next thing I'm going to do is I'm going to remove the voltage. Now there is no battery powering the circuit. You'll notice that the trace climbed on the screen, the actual 0 line climbed. I'm going to drop it back down. We're on 10 millivolts right now. We'll stay with 10 millivolts. And again, I'm going to pass it, this time from high to low. And when I say high to low, I mean I'm moving in the Z. And you can see a change in the maximum and minimum. And this is a surprising result. There's very little EMF when I'm lined up in a particular position to only the upper magnet. So that's I didn't see that coming. I'm sure people will discuss that at length. So now I'm pushing it across, and now it's starting to look like the EMF is about the size of the noise that we're looking at here. But we are still not halfway between the two magnets in the Z-stack. So I'm going to move until we are halfway. You'll notice that the EMF has risen, and now we'll approach the lower magnet, and as before, when we approach the lower magnet on its own, then the EMF gets very low. Finally, I should point out that in the experiment that I just did, that this toroid is vertically oriented. So more video to come showing other positions of the coil, other juxtapositions, I guess we can call it that.